Hi, my name is Joe Vasta, and we are going to look at some formulas that involve pi. Pi would be 3.14159, etc., etc. And our first formula here is the circumference of any circle equals 2 pi r. Okay, now how did people come to this conclusion? Well, what they did is they measured the circumference of the circle, and they measured the diameter. Remember, the diameter is 2 times the radius. And when you put the circumference over the diameter, you end up getting pi. So pi was kind of discovered that way and became more accurate. They got more accuracy throughout the centuries. But there's also a formula for the area of a circle, and that formula you might have remembered from a math class in your past. The area of a circle is pi r squared. So how do we get that without really taking a calculus class? Well, we're going to do that right here. We're going to do something that Archimedes did. So this is what happened. So Archimedes probably did this with a stick in the sand. He took the circle and he divided it into 4 equal pieces. So we're going to rearrange those pieces and put them like that. Zigzag them, I guess. And so the first question is, what is this measurement? Like if you were a little ant and you were walking along that part right there, just the top 2 hills, what is that measurement? Well, isn't that halfway around the circle? So that would be half of the circumference. This right here, these 2 hills, that distance put together is half the circumference. So we know the circumference is 2 pi r. Half of that circumference is pi r. And so if you investigate the bottom curves there, that has a total distance of pi r as well. What is the distance of this right here, this line segment? Well, that's just going to be the radius of the circle. So we'll label that r, and we'll put the r on the other one. So that's what happens if you cut the circle into 4 pieces and sort of zigzag the pieces. Now what we're going to do is we're going to cut the circle up into 10 pieces and zigzag those pieces. We get something that looks like this. Okay, so it looks a little different from this. It looks like this, and I'm going to ask the same questions. You go over those 5 little hills, that total distance is going to be half the circumference. So I'm going to label the top of that with pi r. And of course, the bottom is also pi r. You take the top and add to the bottom. That's the whole circumference, which is 2 pi r. This measurement right here, this line segment, has measurement of r, and so does the one over there. Now here's the part, like so if you've not had a calculus class, this is what integral calculus is about. Chopping things up and rearranging things and finding the areas, and that's what we're doing. So suppose we wanted to cut this circle up into like 100 of these pieces, or maybe 1,000 or 1,000,000. Well, what is this circle morphing into? Suppose my next jump was 1,000,000 of those pieces. It would take me forever to do that physically with a paper circle and scissors. But if you were able to do 1,000,000 of those pizza slices, it would start looking like a rectangle. Okay, so let's say that's 1,000,000 of them. Well, this top part is just a whole bunch of little hills, and that's still going to have the measurement of pi r. And the bottom one has a measurement of pi r as well. This line segment right here has measurement radius r, and the other one is r. So what you have here is this circle is morphing into a rectangle. So with a million or a billion or a trillion, you're getting something that's really close to a rectangle. Now we know the area of a rectangle. It's length times width. So the area of our rectangle that we have right there, we'll place the pi r for the length and the r for the width, and we multiply that together, we end up getting area equals pi r squared. And that's how you can derive the area formula for the circle. So the area of this is pi r squared, and same with that, and same with that, and same with this original circle. I hope you enjoyed this video.